tonight, but I forgot about it.
The co-function. So here we go. So this is the type of thing we're going to be getting into more and more this chapter. This is probably one of my favorite things to do. It says verify the identity. Here's why I say this is one of my favorite things to do. You know the answer. You know the answer. You have to do the work and show me why is it equal to sine over x using your identities. It's kind of like mini proofs. You know, I love proofs from geometry. Okay, so here we go. I'm working on the left side. I want to prove that the left simplifies down to sine of x. So the very first thing I'm looking at is this. So this is one of our co-function identities that we're going to start using. We're going to talk more in depth about. If you take a look on your sheet at the bottom, sine of pi over 2 minus x, that's the co-function identity. It's cosine. It equals the same thing. And we're going to talk about the y in a couple minutes. Now, I hope we know tan. You have two choices for tangent, remember. You have the reciprocal 1 over cotan. I'm thinking about it. I don't know if that's going to help me so much. We also have the quotient identity for tan, sine over cosine. I like that one. I'm going to go with that one. Now, the reason I chose that, because I was like, oh, you have a cosine here, bing, bang, boom, the cosines cancel, we got it, we're done. I'm just going to cross this off. Yep, equals sine. Did it. We did it. So again, starting simple. These are eventually will get more challenging, but we're going to make it nice and easy. So that's what you're working on today, just using your identities, showing how it really does turn out to equal the right-hand side. Okay, odd even. As soon as I see that negative x, I'm thinking it's an odd even. If you don't remember, look on your sheet. Secant is even, so it equals the exact same thing. So I'm just going to leave it. I know it's really times between it. I'm just copying the cos. Now, you got some choices here on how to do this. Just like when you wrote proofs in geometry, you maybe have done them in a different order than I did, but we all get the same thing. You've got choices. You could make secant 1 over, what's secant 1 over? Cosine. That would cancel. You could make cosine 1 over secant, when the secants would cancel. It doesn't matter which way you do it, you'll get the same thing. I'm going to go with Jake's way. I'm going to do secant as 1 over cos. And I'm going to leave that cos. And I'm going to cross those off, and bam, I got the 1, and we're done. So again, as you check these, okay, I may have done it a different way than you did. It doesn't mean your way is wrong. There's multiple ways you could do these things, okay? All right, let's look at this one. Again, we're going to be focused on adding these co-function identities in. So here's one right here. That pi over 2 minus x, that's your tip-off. That's in the co-function. Co-function, just take a look at the list of co-secant and secant. We're going to talk about these more in a sec. I'm just going to copy this one down. And I think I'm pretty much done. Because isn't secant times secant squared, really? Two of them, let's make it quantity squared, we got it. So just using our identities today. Okay, again, first one, I'm like, ooh, negative, odd, even. So cotan is odd, so you get the opposite, so a negative. And I'm just going to leave the secant for now. So remember, we're trying to get to negative cosecant. I'm clearly not there, okay? I got the negative, though, winning, yay me. Here's a pro tip that you're going to hear me say a lot this chapter. If you're like, man, stop. Well, let's, again, try to use our identities and turn everything in terms of sine and cosine, because usually something will cancel out if you go that route. So for cotan, I'm not going to go 1 over, I'm not going to do 1 over tan. I want to use cos over sine. And then same thing, secant, I'm going to go 1 over cos. So I have everything in sines and cosine. And I'm like, oh, I think we've got this. Because the cosines cancel. I've got the negative. And what's 1 over sine? Got it. Because, of course, some of these have multiple identities for them. Cotan, you have 2 choices there. If you're not sure which one to use the one that has sine or cosine in it. Usually something will shake out and simplify. All right. Other thing you're going to see a lot of this chapter is you're going to have to do some plain old boring factoring, but instead of these having x's in them, they're going to have the trig functions, like this one has cosine. Now, factoring rule is still the same. I always look for greatest common factor first. I don't have one, okay? I've got a trinomial, 3 terms, lead coefficient 2. So I have to do that obnoxious factoring where I multiply the outside 2 numbers together. Here's where you might need your calculator, or maybe not. And you have to figure out what multiplies to negative 66 and adds to negative 19. Anybody got it this early morning back after school from whatever? I'll give you one of them. 3, 22. There we go. Which one needs the negative? 22. So we add up to negative 19. Now we're not ready to put our factors yet. What do you have to divide both of those values by? 2. Okay, 3 over 2 doesn't reduce. It is what it is. So to write that factor style, remember the denominator goes first. So I put the 2 first. But I'm not going to put x. We have the trig function cosine. So I'm going to put cos of theta and then plus 3. Now I can do negative 22 over 2 in my head, negative 11. But again, our variable is cos of theta. And of course, if you FOIL this together, you will get that original expression back. So you're going to see there's going to be a lot of factoring that pops up in this chapter, but it looks a little weird with all of these trig functions in them. Now, same thing, I look for a GCF, there isn't, jumps out to me right away. We have all of this as perfect squares, which means we don't have to do any work. Winning. Because obviously to get 9, 3 times 3. So I'm going to do 3 sine of theta for the variable, 3 sine of theta. Okay, and to get 1, of course, 1 is the perfect square of 1 times 1. And then what are your signs? Both pluses, both minuses, or one of each? One of each, so the middle term cancels. You got it. So just some plain old boring difference of perfect square. Okay, again, I'm going to check for a GCF. Nothing, because of the 1's running it for me. Okay, great. 3 terms, trinomial, lead coefficient 5. So I'm going to do the same style of factoring we did on the very first problem. 5 times 1. Got a smaller number though. What multiplies to 5 and adds to negative 6? 5 and 1. Negatives, positives, what do you need for signs on those? Both negatives, like it. And then of course we're going to divide off the lead coefficient. Now I can do negative 5 over 5 in my head, negative 1. But our variable, remember, is tan of x, our very lovely trig function tan of x. Negative 1/5 doesn't reduce. The bottom number goes first. And then our variable. And then the numerator. And again, you can always FOIL it out to double check you have everything in the right location. Any questions on that? All right, almost done with the front. The back's just going to be some co-function identity talk. Okay, GCF. No, not happening. I'm happy though, lead coefficient on my trinomial is 1, so I don't have to get too crazy. I just got to do my times tables. What numbers, 2 numbers, multiply to negative 8 and add to negative 2? 4 and 2, which one needs a negative? 4, so negative 4. So my variable is secant of theta minus 4, and then secant of theta plus 2. So your factoring processes are the very same that we did the very first few days of school. You just have trig functions instead of x in there. Ooh, exciting. Okay, let's talk about co-functions a little bit more, and we're going to practice those. So, let's review. It's been a hot minute since we've done some of this. First, like it says, we're going to draw a 30, 60, 90 right triangle, and let's see if we remember how to draw or label the sides. The triangle, got it. It doesn't matter which angle you mark as 30, which is 60. I'm going to do the bottom as 30. This one is the 60. Okay, and let's see if we remember how to label the sides. Opposite the 30 is what? 1. Opposite 60. Got it. That's about 1.7. And then our hypotenuse along the side. Okay, let's fill in our very lovely trig ratios here, just testing first off, do you remember all the sides and how to do all of this? So of course, tangent, I know you know TOA, opposite adjacent, but you're going from the 30. So opposite the 31, what's adjacent to the 30? Square root of 3. You guys can rationalize that in your head. We got it. Okay, cotan of 60. Now, cotan, of course, reciprocal of tan, so adjacent over opposite. But from the 60, so make sure you look at the top of the 60. What's adjacent to the 60? Adjacent to 61, opposite the 60. Interesting. We got the same thing. Okay, all right. Okay, all right, cool, super cool. Sine, we know opposite hypotenuse from 60. So opposite the 60, root 3, what's your hypotenuse? 2. Well, that was easy. Okay, I like that one. Cosine, of course, adjacent hypotenuse. From 30, though, what's adjacent to 30? Square root of 3, hypotenuse still 2. Okay, let's do these last two. Interesting, we're getting a lot of same answers here. Secant. Secant's the reciprocal of cosine. So hypotenuse adjacent from the 30. Now hypotenuse, of course, 2. What is adjacent to the 30? Root 3. We're going to rationalize. It's all coming back to us. Cosecant, the reciprocal of sine. So I'm like, okay, sine's opposite hypotenuse. Hypotenuse over opposite. Hypotenuse still is 2. From the 60, what is opposite the 60? Root 3. Okay, interesting. Now, obviously, this isn't just random design. I picked these problems on purpose. Okay, because notice, two things we're going to notice. We're going to fill it in here in a second. So notice we have the same answers on these 3 different sets of problems. And one other thing I want you to point out here. What do you notice about all of these angles, 30 and 60, 60 and 30, 30 and 60? They add up to what? 90. And what's our little fancy name for angles that add to 90? Complements. So honestly, I kind of hate the name co-function identities. I feel like it should be complementary identities because it's complements. What the co-function identities are is that your complements get the same answer. So the co-function of tan is co-tan. You get a co on it. Co-function of sine is co-sine. The co-function of secant is co-secant. They always pair up and you'll get those same answers. So let's fill in this. What do you notice about the answers? They're the same. I'm not going to get carried away here. Write a paragraph. I say, what's the relationship between the angles? You just told me they're complements. Okay, that's exciting. So when you do the identities, now I put the radian form in. It could say instead of pi over 290. So if this was my identity quiz, okay, let's practice. So they, of course, always match up to each other, meaning like tan and cotan. So tan, the co-function, or should be complement if I wrote my own textbook, is going to be, of course, equals the cotan. Cotan equals tan. And then, of course, sine and cosine pair up with each other. So sine goes to cosine. That's my dramatic emphasis there, cosine. And cos, I pull the co off, and it goes to sine. Obviously, the final 2 pair up, cosecant and secant. So for cosecant, it already has the co on it. I just yank it off, secant. And then secant, cosecant. Okay. So your next identity quiz is going to be that entire front side of your identity sheet. Reciprocal, which I don't know how many times we've done it. Quotient, done it. Even odd, I think we've done those 3 times. And now it's going to add on the co-function ones to it, just for the record.